Yeah, and the two talks for sure are related because we're also working in the same European-funded project, Flex to Energy. But my topic today is the impact and challenges of using roll-to-roll processes in the industrial ramp-up. And I want to have two messages today. First message is the technology is ready for the production level. And the second message is without this production technology for flexible OPV or perovskite, we will not have a solar industry in Europe within the next 5 years because all the rest will be gone to the US or will stay in China. That's my message today. Short introduction, then short overview on third gen solar technologies, how to scale up, parameters for the roll to roll processes, Industry 4.0, and artificial intelligence, and a summary. So, for the introduction, you find all the information on this QR code, also my talk today. My name is Thomas Kolbusch. I'm Vice President of Coatema Coating Machinery. Coatema Coating Machinery is building coating, printing, and laminating equipment in a lot of deep tech areas, specifically also in renewables, where we work in OPV, dye sensitized, and other technologies already since 2003. We have our own R&D center, R&D team, where we're doing public funded projects besides selling the equipment. And since 2018, we're part of the 88 rolling. Our company vision is from lab to fab. So we do lab equipment, pilot production, and production equipment in different scales. And we are scaling our customers from the small sample into production products. The R&D center itself, 10 people. We can do from process development, test production, education. We have our own coating conference every year, to development of custom-made design for equipment, to public funded projects, the whole range, 10 pilot lines in different size and scale in the operation. So we are working in print electronics, where OPV is a part of for a long time. And the vision was always using printing, coating, and deposition technologies in combination with organic or inorganic chemistry and integrating microelectronics. The USP was the same like the speaker before showed: flexible, thin, robust, lightweight, and also stretchable. It's a huge market potential in different areas. Here you see some of the areas which we also show in different exhibitions and conferences like TechBlick in Berlin and in Boston. So a big topic is healthcare, well-being, Internet of Things, hybrid systems, OLED displays, and all of them need power supply or energy harvesting. And with this, we are coming to the third gen solar technologies. And I mentioned this before. We had printed CIGS, dye sensitized solar cells, then OPV in the 2000s. And since 20 or 2008, people are working on perovskite with some interesting results in efficiency and lifetime. It's not only the coding or printing process, you always have to do a solar module. And in all of these processes, you can lose efficiency. And of course, in all of these processes, you have to reduce cost by optimizing processes, reducing, increasing the yield. But with this, you're reducing also the carbon footprint of this type of operation. Cell efficiencies for third gen solar are, of course, not the same like with silicon wafer technologies, but they have to be measured in a different way. So the overall efficiency over the whole day, specifically early morning, late evening, is all in all nearly the similar approach like in silicon wafers. We have module efficiency, which is the important number because we're not putting solar cells on the roof. These have to be industrially assembled modules. So the efficiency here is up to 1 to 2% less. And you see here some numbers on the perovskite, on the OPV topics. OPV itself, organic photovoltaics, is a fully printed system Nowadays, we also replace